Okay, so today we are going to start the ISS paper 2. Okay, so this the paper 2 of the latest year, that is 2022, this year paper 2, which is in front of you. I am sharing the screen with you right now. So I have arbitrarily chosen some question and I am going to discuss those questions particularly today. Okay, so my chosen questions are, we will start with question number 7. Okay, consider a two-way classified data with 5 levels of factor A and 6 levels of factor B and 4 observations per cell. Then the degrees of freedom of the error. They are asking for the degrees of freedom of the error. So first you need to detect that which kind of model they are actually referring as. Okay, so let us go and see. So this is actually, they said that they have number of rows is equals to this, number of columns is equals to this, and number of observations in each cell is equals to uh, that is like defined, and we are going to find out the data. So 6 level, there for factor A there are 5 levels, for factor B there are 6 levels. So I am considering factor A row wise, so it has 5 levels. For factor B column wise 6 levels, and there are 4 observations per cell. So this basically refers to the two-way Anova model with more than one observation per cell. So whenever I am saying this more than one observation, there are basically two cases. I can say R observation per cell. So that may be Ri for each and every cell, or R a constant observation per cell. So this is the one which we actually refer, that R observation per cell. So and we assume that A has m factors. So as per our formula, m is this. Sorry. We say PQ. So let us write this as this. We say P levels of factor A, Q levels of factor B, and obviously R observation per cell. These are the things we are actually referring to. So here they are asking for the degrees of freedom of the error. So you need to remember few things over here which they have not asked over here, since I am discussing this thing. So I am actually going through the whole table. So for this kind of Anova table, what will we actually, I would like to refer to the Anova table basically. For this kind of thing, the Anova table will look like, this will be sources of variation, that is for factor A, factor B, and the interaction effect factor B. If we don't have this interaction effect, we can't say that there is more than one observation per cell. There will be only one observation, and we say the error, and then we say the total is there. Okay, corresponding degrees of freedom, that I am going to define later. Then there will be sum of squares, and there will be mean sum of squares, and ultimately there will be if statistic, under which we have two categories. One is if observed, which we are going to obtain from table. One is if tabulated, which might be given to you and you can write it. So total of this column is not required. So SS for this is SSA, for this is SSB, this is SSAB, this is SSE, and this is TSS. So corresponding that, this is MSA, which is SSA by its degrees of freedom. This is MSB, which is SSB by its degrees of freedom. This is SSAB, which is MSAB, which is SSAB by its degrees of freedom, and MSE, which is SSE by its degrees of freedom. And if statistics, we are going to have many three tests over here. So for if A, the test statistic is MSA by MSE, and for if B, it is MSB by MSE, and for if AB, that is to test the interaction, it is MSAB by MSE, and corresponding if tabulated you will get. So our focus is on the total degrees of freedom. The total degrees of freedom will be PQR minus 1. For A, we have P minus 1 due to one constraint. Q, we have Q minus 1. Here we have P minus 1 into Q minus 1. And ultimately, if we can add all three and subtract it from over here, we will get PQ into R minus 1. This is the setup which you have to remember. So our focus, what we have to do, we have to find the value of just this thing. So in this way, not only for ANOVA 2-way with more than one observation per cell, for ANOVA 1-way as well as ANOVA 2-way with single observation per cell, you have to remember this table. For our case, P was this, Q was this, and R was this. Let me check it once. It was 5, 6, and 4. So it was 5, it was 6, it was 4. So it is PQ into R minus 1 actually gives you 5 into 6 into 4 minus 1. So 5 into 6 into 3. So that is my actually answer. So let's check out the options. What are the options over here? We have a option 9. Sorry. We have a option 90. Yes. So answer is my 90. So this is my answer. It matches with the option. So for this, it refers to a two-way classified data of ANOVA, and this is the corresponding table. In this way, you can find out the value of any degrees of freedom, but the data is required for finding out the MSA, MSE, and all the other values. Okay. Next, for this thing, we go for question number 8. For the two-way classified data with P levels, Q levels, and M observation person, in my calculation it was R. So fine, it is M over here. They estimate the variance of sigma A hat. So that means we have to estimate the variance of sigma A hat. So if you can see that in by keeping a parity with the ANOVA 1-way and others, we can find out the variances as well. So basically what my sigma A hat is going to give me from the MSA minus MSAB by QM. That thing. The calculation is there. I am not going into the calculation right now. If we have time at the end of the class, we will proceed for the calculation. Okay. Next, I am going for sum number 12. Okay. So it says which of the following assertion is correct or are correct. Maximum likelihood estimate of Poisson mean lambda is unbiased, sufficient and consistent estimator of lambda, and if x follows uniform 0 theta, the maximum likelihood estimate of theta is biased, consistent and sufficient estimate of theta. Okay, so are both the options correct? Neither one, neither two, only one, only two. So let's check the options one by one. As I know the answer, I will say both one and two are correct. But let's check it out. Okay, first we need to find that for the Poisson mean lambda, what is the MLE? Okay, we have to find this. So let's do this. So let us take something else. Okay, so first of all, let me check. Okay, so I'm dealing on a set of n random samples. This is a n random sample, or I should say random sample of size n from Poisson lambda. Okay, so what will be the corresponding joint PMF? The joint PMF will be f of 1 minus n lambda of summation xi over xi factorial. I running from to 1 n. This is a joint PMF. I would like to take the likelihood. So this is called my likelihood. So this is my likelihood. Now I will take the log likelihood. The log likelihood is basically the natural log of the joint PMF. What is this? This is the natural log of joint PMF. So that is basically log of e to the power minus m lambda plus log of lambda to the power summation xi minus log of product of xi. This is the thing. Now we are going to do the derivative of the log likelihood. First order derivative with respect to lambda. That is going to give me, let's check out the log likelihood function. That is going to give me minus n lambda. Okay, let's simplify this a little bit, then we will go for the derivative. So it is actually giving me minus n lambda plus summation xi into log lambda minus log of this product over x. I am keeping this as it is because this is independent of lambda. So whenever we are going to do the derivative with respect to lambda, it is going to be 0, obviously. So this term is basically independent of lambda. Okay. So now moving on to the derivative, it is going to give me minus n plus summation xi into 1 by lambda plus 0. Okay, so that basically comes with, now we need to do basically we need to equate this first order derivative with 0. That is going to give me summation xi by lambda is equals to n. So that gives me lambda hat or the estimated value of lambda. I can't write MLE right now because I am not sure that whether it is MLE or not. Lambda hat is equals to summation xi by n, that is equals to x bar. So what this is called? This is called the estimated value of x. Sorry, lambda, estimated value of lambda. Okay, now what we have to check that whether this gives me the maximum likelihood estimate or not. For this, what we have to do, we have to do our double derivative of our log likelihood function. So basically the first derivative of the log likelihood function was something like this, referring as star. So I am going to do another derivative of this. So if you can see it very carefully, this term again is independent of lambda, that is going to go out of the summation, and we are left with only the derivative of this thing, summation xi into 1 by lambda. So that is going to give me summation xi into minus 1 by lambda square, and I have to estimate this at lambda hat equals to x bar. Whatever be the value of lambda, this thing is basically negative, but not whatever be the value of lambda, since the value of lambda is basically positive over here. So that and also like irrespective of whatever be the value of lambda, I said, because there is a lambda square. So whether it is negative, whether is it positive, since this term is positive, this lambda square term is positive, this negative signs actually generates this whole thing negative. So the overall function, log likelihood function, is increased. So the log likelihood function is maximum. The log likelihood function is maximum at lambda hat is equals to x bar. So basically this is my MLE. So lambda hat MLE is equals to x bar. So now I need to check whether this is the first procedure which we have done, that maximum likelihood estimate of Poisson with mean lambda. What is that we have obtained first, then we need to check whether they are unbiased or not, sufficient or not, and consistent or not. Okay, so let's check this out whether it is unbiased or not. So what is t estimate of theta is called unbiased estimate if expectation of t is equals to theta. So this lambda is an unbiased estimate of x bar if basic, or this x bar is an unbiased, sorry, this x bar is an unbiased. And what is this t basically? This is nothing but a statistic which is a representation of the sample. So I need to show, so to show, this is my objective over here, or rather I should write to check, not to show, to check that expectation of x bar is what. So I will proceed and I will write expectation of 1 by n summation xi, this thing that will write 1 by n summation over expectation of xi. This expectation can go inside by the additive property of expectation, and also since this is basically uh, IID sample and random sample. So 1 by n into lambda. Since xi follows Poisson lambda for all I, that implies expectation of xi is equals to lambda for all I. So that's why for expectation of xi we have given lambda. So this expectation of xi gives you the value lambda. So hence it is unbiased estimator. So we can tick on that. Since it is unbiased, obviously since there is no other option, what you can do, you can skip and check that yes, it is sufficient and it is consistent, because we don't have, the next distribution is not on lambda, so, and you don't have any other options. Okay, so basically if it is unbiased, it is going to be, that means one option is true, so it is also sufficient and it is consistent. So let us check the sufficiency. Since this Poisson lambda distribution is completely sufficient, is completely sufficient, hence this x bar is an sufficient statistics, that I am not showing because this is not the part of the discussion today, and also this is going to be consistent. I can show it by using the sufficient definition of consistency, that expectation of x bar will tend to theta, sorry, will tend to lambda, not theta, will tend to lambda, and variance of x bar will tend to 0 as n tends to infinity. This is not the full condition, this is the sufficient condition. Okay, so based on this two things, we can say that one is absolutely correct. And for question number 2, or sorry, for the statement number 2, coming to the statement number 2, they say that x follows uniform 0 theta. This is the actual thing. If x follows uniform 0 theta, then the maximum likelihood estimate of this theta is biased, consistent and sufficient. So what is the maximum likelihood estimator? I am not showing it right now, but x order n is the MLE, of theta over here. So if x order n is the MLE of theta over here, then basically it is biased and consistent and sufficient. So both 1 and 2 are actually correct. Is it okay? Next, moving on to say question number. Okay, let me check this. Question number 27. Okay, the same kind of thing. Consider the two-way classified data with our observation per cell. And this is the thing. It has P levels, Q levels, K running from R. Consider the Anova table. Due to A, it has T degrees of freedom. Due to beta, it has U degrees of freedom. Due to interaction, it has V. Due to other, it has this. And due to the total, it has basically PQR minus 1 degrees of freedom. Okay, so basically what is the value of T, U, V and W? We know this is P minus 1, already I have discussed. This is Q minus 1 and this is for the interaction P minus 1 into Q minus 1 and this is PQ into R minus 1. So let's check which option is correct. P minus 1, Q minus 1. Basically, they are asking for this value respectively. T, U, V, W. T, U, V, W. So P minus 1, which option starts with P minus 1? Basically, is going to be the correct option. This one is the correct option. Because it is referring to the table which I have just made at the starting of the class. That's why I made the full table. Basically, there was no need of making the table. Okay, if you can see this particular model, one-way classified data, the exact one-way ANOVA model, and the testing of hypothesis is this. Consider the ANOVA table as this. So let us go and make the ANOVA table of one-way classified data. Just a minute. ANOVA table of one-way. For this ANOVA table of one-way, we have sources of variation. Next, we have degrees of freedom. Next, we have sum of squares. Next, we have mean sum of squares. And lastly, we have if statistic. Wait, I think I have lost the connection from my PC. Just let me rejoin in 1 second. Just a minute. I lost my network. Is the screen visible?
Yes, ma'am.
Okay, just got disconnected, sorry. Okay, so we have two kind of if statistics. Just a minute. We have two kind of if statistic. One is if observed and one is if tabulated. Okay, so for sources of variation we have SSA, SSE, and for the total we have TSS. Okay, for the degrees of freedom I'm not writing it right now. Sorry, extremely sorry. This is factor A, this is factor A, this is error, and this is my total. Okay, so this is SSA, this is SSE, and this is my TSS. This is MSA, which is SSA by its degrees of freedom. This is MSE, which is SSE by its degrees of freedom. So we didn't need the total over here, and we have two test statistics. We have only one test statistic if, that is MSA by MSE, and we can get the tabulated as per the table. Okay, so what will be the total degrees of freedom for this thing? The usual convention says what they have used, that is the usual convention of the data, the usual the theory. Basically they have said that the usual theory says that k minus 1, this is n minus k, and this is my n minus 1. So what as per my problem is over here, let me check. For my problem, it says this is u, this is v, this is capital N minus 1. So they have just changed it a little bit. This is u, this is v, and this is capital N minus 1. So all of the thing where I have used small n, they have just used capital N. So as per my thing, u will be k minus 1, v will be n minus k, and the total is basically is n minus 1. So let's check this out. The option, what are the options? K minus 1, n minus k. Option C is the correct option. Is it clear? Just you need to do the like changes, and you just have to equate it. That's it, nothing else. Okay. So next we will move on to question number 68. Okay. For question number this, we have some data. Okay, so we actually have some data, and what we have to do, we have to actually try this, that what are the values of this particular thing. So what are the required thing given from 68, 69, all those questions, it is based on this particular data. So let us write this data first. What is the given data? The data is summation p naught q naught is 782. Summation P naught Q naught is 782. Next is summation P naught Q1 is 1008. Summation P naught Q1 is 1008. Next is summation P1 Q naught is 1084. Sorry, it's P1 Q naught. Okay. And next is summation P1 Q1. So all possible combination of weights. So the value are 1084 and 1329. 1084 and 1329. Okay, these are the corresponding values what we actually have. Okay, now basically what we have to do, we have to find the index numbers given, or the corresponding index numbers. Okay, so what are the index number what we have over here? They are asking for Fisher's ideal price index for P not 1. We are denoting it P not 1. Okay, so let's write it over here. Number 1, what we need, Fisher's ideal price index number. This is what we need. Okay, Fisher's ideal price index number. This is what we need. Next, what we need, this is corresponding to 68. Fisher's ideal price index number P1 naught and P naught 1 and P1 naught. If you can see this, this is taking base year as 0, current year as 1, and this is base year as 1 and current year as 0. Okay, and the same thing Fisher's quality index. We also need this quality index as well. Okay, so we also need this quality index as well. So this is the quality index number. So Fisher's quality index number, this is P naught 1 and this is P1 naught. This is quality. This is Q given by, let me check, Q naught 1. Okay, so let's write up the formulas. What are the formulas? Okay, can you tell me what is Fisher's ideal index? I don't know, but if you can remember, I told you the Fisher's index is basically like based on last year's and passes index. So what we have to do, we have to find the last year's and passes index as well. So last year's index of 0, 1, that formula is summation over P1I and basically Q naught I by summation over P naught I Q naught I. Okay, so this is for naught 1. Okay, so we can obtain this. Similarly, sorry, similarly for P naught 1, what we are going to have basically is summation over P1I Q1I divided by summation over P naught I Q1I. Okay, this is corresponding to naught 1. And what is Fisher's ideal index? The Fisher's ideal index is basically nothing but, let me write it over here. The Fisher's index is nothing but the crossover L into P. Okay, the geometric cross of this. So basically I can write this naught 1 is L naught 1 into P naught 1. So I can get the value of this naught 1 from this particular number, that is P1 Q naught. We can ignore the I because they are doing a summation. So the summation is over I and also the total of the values is given to me. So what is P1 Q naught? P1 Q naught is 1084. What is the value of P naught Q naught? The P naught Q naught value is given as 782. So this is my first value. What is the value of P naught 1? This is P1 Q1 is 1329 divided by this P naught Q1 is 1008. So this is this thing. So we have obtained if naught 1 is equals to 1329 by 1008 into 1084 by 782 and the square root of whole thing. Is this clear? Is this clear?
Yes, ma'am.
Okay, next moving on to the what they have asked for is Fisher's ideal English. They have given P not one, just I have changed the notation as F not one. So P one not. Okay, so these are all basically price indexes. That's why. So P not one. So like I need some last year's index of L not one and L. So basically, if not 1 is going to be obtained from L not 1 into P not 1 square root of that. So you have to tell me the formula of L not 1 into P not 1. What will be the formula of L not 1? Let's check out the formula of L1 not. Here, not 1, sorry, 1 not. It's going to be 1 not. Sorry. Okay, so this is the basic formula. So let's check out the formula of not one. What not one says, in not one, if you can see that the weight was not, that weight was taken, since not defined the base year, the weight was taken of base year. And since we are always obtaining the price index, we are always obtaining the price index, the ratio of the price was taken P1 by P naught. Okay, so what we are going to do, we are going to apply the same theory over here. This is my not price index, this was the quantity index or price index they have asked for. They have asked for again the price index as well, but changing the year. So this is again the price index. So I will write P1I by P naught I. But since this is 1 naught, I will use Q1 I by Q1I. So what is the difference between the formulas? P1 by P naught are same, but instead of Q naught, I have just used the weight Q1. Okay. So what was the combination? The combination is P1 Q1 by P naught Q1. So P1 Q1, let's check. P1 Q1 is 1329 by P naught Q1. P naught Q1 is 1008. Okay, so here also, what is the formula of passes formula? The passes formula is P1 by P naught, and they have used the weight as Q1 because it was the formula of P naught 1. Okay, so I am going to use P1 naught. Okay, since I am going to use P1 naught, so my weight will be Q1 as well. So basically, this doesn't going to change, and this is going to give me the corresponding value P1 by P naught into Q1 by Q naught by Q naught. So let's you put the value and you find out the thing. First, let us try that whether the first one value is actually matching or not. Can you can you find this value and tell me whether it is correct or not? Can you please find out this value 1329 into 1084? Anyone who can answer? What's the value is coming? If you can see, the value is coming at 0.0015 something. So it is basically the approximate value of Fisher's index, ideal price, Fisher's ideal price index. Wait. Let me check out the formula. I have written something wrong, I guess. Just a minute. Can you please check out the values once again? Let me rub this. This is creating the more confusion. This is a value. So we are actually finding out Fisher's ideal price index number. So let me check the question once again. Just a minute.
Ma'am, here we have to multiply by 100.
Yes, the approximate. Can you multiply and tell me the value? I am checking the formula actually, whether I have written it wrong or not. It's coming approximately 152. It's not close to the. No, wait, let me check the formula again. This is the last year's formula. Just let me go through the formula again. Let me just I'm checking the formula. Wait. Okay, so this is my last year's price index, and this was my wait. Okay, this was my last year's price index. This was my okay. Let's rub it from over here. Okay, let's check this out again. Okay. So the thing is that we will put the values later. Let us write the formulas first. Okay, so L not 1, P not 1, this is the price index number. These are basically last year's price index, and these are passes price index as well. Okay, so both are last year's and passes price index. So let us write the quantity index. The quantity index formula are given by uh, L. The quantity index formula is given by L naught 1 is equals to summation over Q1I P1I by summation over P naught, sorry, summation over Q naught I P1I. This is last year's quantity. Okay, this is last year's quantity index. And what we have again is passes quantity index P not 1. The passes quantity index is given by, sorry, this is going to be P naught for last years, and for passes it is going to be summation over Q1 by Q naught into P1I by P naught I. Okay, so this is also for passes quantity. Okay, so this is last year's quantity, passes quantity, and this thing. So what we have to find, let's see what we have to find. All the like materials are over here. Let's say we need to find Fisher's ideal price index number P not 1. Okay, so we need to find some index number which is called P not 1. That is, the base year is 0 and the current year is 1. So P not 1 is going to be the product of L not 1 into P not 1, and this P not 1 is Fisher's price index. This is price. For price we are finding. So for price, the value of L not 1 is basically summation over P1I Q not I divided by summation over P naught I Q naught I into the P naught 1 for price. P naught 1 for price is this formula, P1 Q1 by P naught Q1. P1 Q1 by P naught Q1. Okay. So what I was doing the mistake, I was changing the weight only. That is not the solution. They are asking for the quantity index in the next case. That where I have done the mistake. Okay. I will tell you later in details. So this is the thing what I am actually searching for, and I will need to put the values. You can put the values and tell me what are the given thing is. Okay. So now I will go for finding P1 naught, that is L1 naught into P1 naught whole thing. This is not P, let it be F. For our convenience, let it write as F for Fisher's. Okay. So this F, a 1 naught is this thing. So 1 naught means taking base year like this. So the above formula, let us refer to the above formula. In the above formula, wherever there is 1, we will replace it by 0. Wherever there is 0, we will replace it by 1. So summation P1I Q naught I, P1 Q naught, P naught Q naught. So let me write this first. It was P1 Q naught, so we will write P naught Q1. This thing. Next we have P naught Q naught, so we will write P1 Q1. Over here it is P1 Q1. We will write P1 Q1 was there. So we will write these two, P naught Q naught, and this is P naught Q1. So we will write. Okay, now you need to find the value of this whole thing, and you need to tell me whether the values are coming right or not. So P1 Q naught, let's check out the value. P1 Q naught is 1084 into P1 Q1. P1 Q1 is 1329 divided by P naught 1, P naught Q1. I think the first value 1008 into P naught Q1. P naught Q1, that is 1008. This is going to be the particular value. Okay, you calculate this and tell me what you are actually getting. And over here, the value is basically P naught Q1. Let's check the value. P naught Q1 is 1008 into P naught Q naught. P naught Q naught is 782, and this is P1 Q1 and P1, this is also going to be P1 Q1. Okay, let's check this formula. Wait, this is P naught Q naught. This formula I have, I think, written something wrong. This passes price index, I think I have written something wrong. Let me check this passes price index. This is P1 by P naught into passes price index P1 by P naught into Q1 by Q1. No, it's fine. No, it's fine. Okay, so that is the formula. P1 Q1 P1 Q naught. P1 Q1 is 1329 and 782. Okay, so that is the value you have to obtain. This is P1 Q naught. Wait. 1084. This is going to be the value. Just see and check the values. I am not sure about putting the values since I am scrolling up and scrolling down continuously. So you just put and see the values. I am just giving you the formulas. Now it's basically the last one is the Fisher's ideal quantity index. Like I told you, the quantity index formula is given Fisher's ideal quantity index. That is this Fisher's quantity index not 1 is L not 1 into P not 1 square root, and this whole thing is going to be for quantity. This quantity means the formula is going to be this thing. That is Q1I P1I by Q naught I P naught I. This is Q naught I P naught I naught I. Okay, so you can calculate this value, I guess, and then you will going to get the estimated value. Just put the values correctly because I am not putting the values correctly. I am not getting into this thing. Okay, I am just giving you the formulas. You just have to see and put the values correctly. Okay, I am not
Okay,
giving
ma'am.
you the values right now because since I am scrolling up and scrolling down, I am continuously writing the wrong values and hence the answer is coming wrong. But I think hope you have understood. But for here, the main problem is coming over here. This is for price as well, for base year as one. Okay, so this here you have to change the whole thing, whole setup. This is very important, which is very unusual. The rest of the thing is as usual. And this is the quantity index. Is that clear? These formulas are a little bit confusing, but if you can write in a list and if you can make a chart for Laspier's and passes and Marshall Edgeworth and for price and quantity, and if you can make a chart like this and you can write all of the required formulas over here, from here you can actually make any kind of combinations, and you can make Fishers, you can make Bowleys, any combinations you can make, and you can find out the values from over here. And even you can like make the chart more interesting by taking 0 1 as base year, 0 1 as 10, and again 0 1 and 10, the taking the reverse thing as well. So you are going to have two tables all together. Okay, so that table is going to help you to obtain the values as quickly as possible, and you have to remember the formula so you don't take that much time which I am taking right now just for explaining. The formula will be just with you just have to replace it. That will be a suggestion from my side. Is it okay? Is there any queries? Hope not. There is no query. So just a minute.
Thank you, ma'am.